Zero knowledge proofs have skyrocketed in popularity this year, transforming the way we see privacy, security, and scalability. So to help us better understand this growing and diverse field of ZK proofs in blockchains, I've created this table which we can use to categorize each blockchain. This research is still ongoing, so if you spot any errors or you have any insights to share, then please leave it in the comments below. Earlier this week, Vitalik also posted this article which highlighted 3 things that Ethereum needs to succeed, 2 of which involves privacy and layer 2 scaling, which also can be aided by zero knowledge proofs. So I think now is a really great time to start talking about zero knowledge proofs and understanding how it works across different blockchains. One of the most popular applications of zero knowledge proofs is actually scaling Ethereum. This type of blockchain solution is called a ZK Rollup, and if these blockchain solutions also have some level of EVM compatibility, it's also called a ZK EVM. And by having EVM compatibility, that makes it easier for developers to use the existing applications and tooling so that they can deploy for these layer 2 blockchains. Having EVM compatibility is huge for blockchains. So let's filter this table and see which ones have layer 1 compatibility. So all of the blockchains that have layer 1 compatibility also are layer 2 blockchains because they're scaling Ethereum, but unfortunately they don't have any privacy features natively enabled in the app. Layer 2 solutions involve 2 others that weren't there before, which is Aztec and Starknet. So they both are layer 2 solutions, which means they are ZK Rollup and they aim to scale Ethereum in particular, but they are not EVM compatible. So if you are writing for the Aztec blockchain, you are not using Solidity, you have to use Noir. Even though Starknet is not EVM compatible, it does have some sort of way for you to transpile Solidity code into Cairo. However, if you're a developer, you're now going to have to maintain 2 code bases, which is the Solidity version of the application and the Cairo version of the application. But one thing I find really interesting is that Aztec also has privacy in dApps. So let's talk about the private nature of zero knowledge proofs and how that can be used with blockchains. So there's an increasing desire for privacy in blockchains. Since most transactions on a blockchain are financial in nature, not everyone would like that information to be public. Though your address does make you kind of anonymous, if you do things like associate a name with your address, then that can remove some level of anonymity. One notable advantage of using zero knowledge proofs in blockchains is the ability to achieve privacy enhancements, such as private inputs, private smart contracts, etc. So if I look for some of the ones on here that do not use Solidity, then we can see that almost all of them actually do offer some privacy in their dApps, whereas Starknet is one of the ones that don't actually do that, as far as I can see from the documentation anyway. So if that's not true, please leave a comment below. And another thing that's interesting is that Aztec blockchain is the only layer 2 solution that actually does have privacy in dApps. According to Aztec's documentation, developers can build apps that actually allow for user privacy, data privacy, and code privacy, which essentially means that the sender and recipient will be private, or the data sent in the transaction can be private, and even the code for the smart contracts can also be private. They also have their own programming language, which is called Noir. Mina blockchain is another protocol which does allow developers to use ZK proofs in their smart contracts, which does enable things such as private input to smart contracts. That means the data that the user sends to the smart contract can remain private. Even though majority of the blockchains that do use zero knowledge proofs, all layer 2 solutions focus on scaling Ethereum, they are not all like that. Of course, this is not exhaustive, but if I filter for layer 1, then we can see there are a few blockchains that are layer 1 blockchains that do use zero knowledge proofs in their implementation. So what that means is that it is not batching transactions and sending it to Ethereum as a security layer, but instead these layer 1 blockchains that are using ZK proofs are actually depending on its own consensus and validation mechanisms for security. That means for these layer 1 blockchains, it most likely will benefit from things like fast transaction, low transaction fees, as well as privacy in dApps because they all have their own programming languages. It allows them to do things like provide the availability for developers to implement zero knowledge proofs within their smart contracts. So if you are a developer and you'd like to build a dApp on a zero knowledge blockchain, there are 2 ways you can do it. So there are the traditional blockchains or the traditional layer 2 blockchains that have some level of EVM compatibility or not, and they allow you to just write apps in the way that you're used to. For example, you can use Solidity to write an application on that blockchain. You can take your existing Solidity code, deploy it on the layer 2 solution. By deploying it there, your app can benefit from faster and cheaper transactions. So for example, if you'd like to build for ZK Sync or Polygon ZK EVM, then You would have to just take your testnet ETH and bridge it across to that blockchain. And you can use the same tools for deploying these applications such as Remix and Hardhat. So that means for a Solidity developer, you can easily build for these ZK Rollups and you can benefit from ZK proofs. Another way in which you can build dApps within these zero knowledge ecosystems is that you can actually utilize ZK knowledge proofs within your smart contracts and create something called a circuit, which is basically a representation of that zero knowledge proof. So you can benefit from the attributes of a zero knowledge proof, which is you can prove that something is true without revealing underlying information. So you can do that on blockchains like Mina, Aleo, LF0. And if you are someone who's already a TypeScript or JavaScript developer, then building on Mina will be a lot easier because they actually allow you to write smart contracts with TypeScript. I do have a full video to show you how to do that on my channel, so definitely check that out. If you're more familiar with Rust-based programming languages, then definitely check out Aleo, LF0. They both have their own language for creating these smart contracts, but I believe they're Rust-based. Even Aztec, which is a layer 2 solution that does allow you to implement ZK proofs within their smart contracts, they have their own programming language, which I do believe is also Rust-based. This research is not exhaustive just yet, but there are things to consider, such as, is the prover decentralized? So the mechanism for proving these ZK proofs, is that decentralized? Also, what type of ZK proof are they using? Is it a ZK snark or a ZK star? The level of EVM compatibility is also one to consider, because the more EVM compatible it is, the more tooling and debugging tools can be used by Ethereum developers. We can also focus on how interoperable these protocols are. So if you find this interesting, then definitely leave comments and subscribe to this channel. A like goes a very long way. Thanks so much for watching and see you in the next one. Bye.